Well, hey everybody, and welcome to Network Maintenance Live. I am Justin Ribber, host of the Sysadmin Show, and this is a live series I've been doing on Tuesday nights, talking about everything relating to network maintenance. That's when I typically do my network maintenance, and best practices, tips, tricks, everything relating to updating your IT infrastructure. So today I want to talk about virtualized storage. And just recently, in the last couple of weeks here, I ended up needing to upgrade or expand some storage on one of my SANs, and that got me thinking about kind of the big picture, the top level. How many of you have experience with it and would maybe need a little bit of a refresher? So I did a refresher for myself, took some notes, and I'm just going to go over that here. So basically, let's start from the highest level, the SAN. This is a storage area network, and this is where we go to get all of our storage for the virtual environment. And the SAN is divided up into LUNs. So a LUN is a logical unit number. I actually had to look that up. I've used the term LUN a lot, but I had no idea that it actually stood for a logical unit number. And when you're carving out a part of your SAN to be a LUN, typically you want to leave 10 to 20% of that free and like unallocated, not passed on to anything else, so that it has a little bit of a buffer. And we'll get more into that later. So the next level is your hypervisor storage. And a hypervisor is whatever technology you're using to virtualize. So this could be VMware, this could be Hyper-V, any of those kinds of things. And on a hypervisor, the storage is typically called a data store. At least with VMware, that's a common terminology. So again, best practice when you're filling up and adding things to a data store, you want to leave unallocated about 20% of that. Next is your VM storage. So this is the actual virtual machine that you're deploying on the hypervisor, and these are typically called virtual disk drives. You can have more than one attached to a particular VM, and again, you want to keep some percentage of that disk drive. So now you're in your server OS, and what do you want there, right? I typically shoot for 10% free, right? I have reports and alarms that go off in my environment if any VM gets within, over that 90% consumed level. Lets me know, and then I go in and expand the storage as necessary. So maybe you want to be a little bit more cautious and make that 15 or 20%, whatever works for you. So how do all these play together? Well, it really depends which technology you're using. So it used to be a situation that all SANs were spinning disks, and so they had a decent amount of performance depending on the RAID configuration they were in, but they were not as fast as what is now considered the all-flash arrays or even the hybrid arrays. So some things have changed, and there's two ways to basically deploy either a LUN or a VM storage, a virtual disk drive. The first way is called thick, which you actually use up all the storage that you are allocating at that time, and you basically just fill it with zeros if you're doing what's called lazy, or you just leave it kind of alone if you're doing what's called lazy thick, and that way, if you want 100 gigs for a server, you're giving that server 100 gigs. If you want to, in the SAN level, if you want to out of a LUN, if you want to give 100 gigs to the hypervisor, you actually lose, right? You use up 100 gigs of storage. So that's pretty much the standard for when you were working with spinning disk drives. Well, that's all changed now with SSDs. So you can actually do what's called thin provisioning, and actually I reversed that. So with the with the spinning disk drives, you wanted to do thin, because that way you had the ability to over provision. So if you needed to give out more space than you had, you could do that with thin provisioning. So with all flash arrays, there's something called thick provisioning, and it's really become more popular. So what the main change is that all flash arrays have a couple of technologies available to them because they're so fast. One of them is compression, and another one is deduplication. So on the fly, these arrays now can not only compress your data, but also find any duplicates in the data. Let's say that you have 10 installs of Server 2019. Well, one of those copies is necessary. The other 10, or the other 9, is not necessary because they're all the same bits. So it can just point to that, and that's deduplication. So these new all-flash arrays are able to do this on the fly and still give you extremely high performance in a lot of IOPS. And that has allowed the best practice to change from thin provisioning and everything to thick. And if you think about why you needed to thin provision before, and let's get back into that because I kind of got confused there. Right, if we've got 100 gigs available on a LUN, and we want to give 80 gigs of that because we're going to save 20% to our hypervisor, right? And then we know on our hypervisor, we want to leave 20% free. So now we're only doing 20% of that. And then on our VM, we know that we want to leave 10% free at least. So now we're working on that. You can see pretty quickly, we're using up a lot of our production storage, which is fairly expensive, on these reservations. And one way to get around that is I could say, okay, on my LUN, I'm going to provision 100 gigs, but I'm going to do it thin. So I don't actually use up that 100 gigs in the SAN. It doesn't get eaten up until the hypervisor claims it. And then the hypervisor creates a data store, and that's going to be, let's say, 80 gigs. So then only 80 gigs of that 100 gets used up on the LUN, right? And then when I get down to my virtual disk, I'm going to make that thin, and that thin provisioned is, let's say this is a 50 gig VM, which is actually really small these days. But if I provision that thin, actually it could be a 100 gig VM, I could provision that thin, but only the OS is installed so far, so it's only using 10 to 20 gigs of data. So the end result is I've provisioned a lot more storage than I'm actually using at the time. And nothing goes wrong until I start to eat up into that storage. And as I start to eat up into that storage, I hit those reservations and alarms go off. And before I run out, it lets me know that I need to expand the LUN or expand the data store or expand the VM. And that all worked really well. But it was a lot of maintenance. Constantly, when I had a physical disk SAN array, I had to go through and constantly babysit those, either over provision everything and kind of eat into my storage, or I had to go in and constantly maintain VMs and LUNs and data stores and constantly grow them and shift VMs around as necessary. Well, with all flash, that's all changed because the compression and the deduplication is happening, and so all of that over provisioning gets taken care of by those technologies. So I can go in and create a thick provisioned LUN of 100 gigs and give all 100 of it to the the hypervisor, and then I can take that hypervisor and I still leave 20% free there because that doesn't have thick or thin provisioning technology. But then at the VM level, I do thick provisioning and I give it 100 gigs, right? Or whatever I have available, 80 gigs, let's say. That's what I have available left after saving 20%. So now my VM, again, is not using up all that, but let's say it only uses up 20 gigs for the OS and a few apps. Then I have 60 gigs unused, and that's empty space. Well, my SAN is going to take that empty space and compress it, and I'm going to get that space back. So then you have what's called a compression factor or kind of a deduplication factor. And you'll look in your SAN if it's all flash and it's running these technologies, and you're basically getting 1x, 2x, 3x, maybe 16x, depending on how much duplicate data and how much compressible data you have. And you now have how much data raw is available on your SAN. So let's say it's a 20 terabyte SAN, right? And then you have how much data is used, and you could be using up, if you're getting a 3x compression ratio, then you could be getting 60 terabytes of data stored on that SAN, even though it's only a 20 terabyte SAN. And that's kind of changed the finances, the financial aspect of SANs, and the all flash. They're actually worth a lot more because they can store a lot more and give better performance. So that was a quick overview. Hopefully most of that made sense. I got a little turned around in there. But I wanted to go over some of the storage changes and some best practices around SAN storage and give a rundown in case anybody wasn't familiar with it. So I want to hear from you. Any questions or comments, leave them in the video below. If you're interested in hearing more from the Sysadmin Show, go to sysadminshow.com. Check out the podcast. You can find it on all of the places you find podcasts. Just search for it. You can email me, Dustin at sysadminshow. And until next time, I encourage you to never stop learning.